Hello, welcome to this webinar here at Qoitech. So this webinar will be about automation of power measurement. This webinar is recorded and a link will be mailed out to you, also together with the trial license. If you have any questions, write them in the chat. And the chat is moderated, so either it will be answered directly or I will try to bring it up in the Q&A. So my name is Björn Rosqvist. I'm Chief Product Officer here at Qoitech. I have a background in power electronics, automotive, and telecommunication. My focus is in design and verification, and I'm specialized in low power design and also batteries. This webinar will mainly focus on automation toolbox. So by that said, no real focus on using the tool OT3 in itself. That will come in a separate webinar later on. So the agenda. First, I will have an introduction of the Automation Toolbox license. Then I will talk about the languages that are supported. I will show two examples. One is scripting together with the Opti UI, and the other one is scripting without having a UI. Then in the end, I will show a little bit more advanced use case where I am integrating scripting and power measurement into a build server, in this case Jenkins build server. So let's start with the introduction of the Automation Toolbox license. So all information is on our web page. So if I open up the Automation Toolbox, there's a lot of information here on this page, an overview where you can read about the different possibilities that the toolbox gives. There is a section of frequently asked questions, and there's also documentation connected to this. If I click buy, so the foundation to all the toolboxes are the Pro software. So if you have bought an ARC Pro or ACE Pro, it comes with a 1-year license of Pro. So then you can add on the toolboxes onto this Pro license. So you can buy them monthly, yearly, and you can buy them perpetual. If you do not have a Pro license, it's possible to buy a Pro license and then add on the toolboxes. If you have an OT2 license from previously, this also works in OT3. So moving to the application, if I log in, so all the licenses are connected to the user. So when you log in with your user, you get access to your licenses. If you want to use a function, you need to reserve the license, and then it's being connected to the computer that you work at. When you're done, you will return the license. So it's very easy to use the licenses, reserving them and returning them. So if you work on many computers, and make sure that you remember to release the license before moving to the other computer. If you have bought an ARC or ACE Pro, when you register your product, you will get your Pro license activated. If you have ARC from previous, if you register that, you will get a standard license, a perpetual license. And the standard license is the same feature set in OTI 3 that you're used to in OTI 2. So the same feature sets. So after this webinar, you will receive a Automation Toolbox trial license that you can try out. So the languages that are supported, let's talk about that. So if I go to the documentation page, user manual. By the way, in our documentation, you can find a lot of information how to use this tool, also with advanced guides, and I will walk you through that as well. So information about Automation Toolbox can be found here. So what we are using is a generic TCP server API. So that means that we support more or less any scripting languages. In this webinar, I will be showing Python, and on our GitHub, we have implementation in some of the most popular languages like Python, C#, Java, and MATLAB. So looking into the GitHub, here we have the Python client, C#, MATLAB, and Java. So let's look into the Python part. So here you can find examples. So it's very easy to start scripting. You can just start with our example and evolve that to whatever you like to do. So start with our example is the, I would say, quickest way to start using. So back to the documentation, if we move to the advanced guide, there is a description here about scripting with Python. So here you have information about how you install the Python client and a lot of information about running the server and some scripting here that you might be handy when you start. We also have a help, the APIs for Python. So looking at the ARC APIs, for example, the ARC APIs is also available. It's the same APIs for ACE, of course. So there will be new APIs coming continuously. So as mentioned before, if you have any questions, just write in the chat. So moving into more live use cases, so scripting with or without UI. So I will have two examples of this. So scripting with UI, then I don't need to start the TCP server. When I start the UI, the application, it's turned on automatically. So what I need to do is I need to sign in and reserve my license for it to work. And to show you the setup that I will be using. So here on my desk, I have an AUTI-ACE connected to a particle argon board. So I power my particle through the main terminal, and that is connected then to the battery terminal of the particle device. As you can see, I have more cables connected here on the expansion port, and that is that I have on the particle argon connected it to the UART of particle argon, so I can listen to the messages, listen to the data that the particle argon is sending out, because in the firmware we have implemented debug prints, so it's being sent out on the UART what the device is doing, when it's going to sleep, when it's connecting with the Wi-Fi, and so on. And the Python code I will be running is a voltage sweep. So here in the code, here is the host, and this is how I connect to the TCP server. This is the default values, and you find them by going in the OT application to preferences. Here you can see the default values. So if you need, you can change that here. And what I am doing is that I have a function here that waits for a message. So and that means that I actually will read on the UART RX channel and look for a specific message. And if I do not find the message, I also have a maximum timeout. So if I find a message that matches, then I will output the timestamp when this happened. And if I don't find the message, I will send out that the message was not found. Here's the part where I connect to the server. And also this is the same as you will find in the GitHub examples. Then I need to connect to my device, my ARC or ACE. So I get a list of devices. In this case, I have only connected one. So I connect to the first one. But it could also be that I rename my device. In this case, my ACE has the default name, and that is ACE. But I could have renamed it to something else, and then I can connect to a device with a certain name as well. So if you have several devices, you can just rename them and connect to them specifically. Then I have a setup phase. I will enable main current channel, main voltage, main power, and the UART RX channel. Then I set up the sample rate. The default value for ACE is 50,000 samples per second, but I'm not interested here in this demo to show that high sample rate, so I set it to a lower value. I set it to 1,000 samples per second for these analog channels. Then I set the voltage. Starting voltage, I have 3.9 volt. I set the overcurrent setting, so I have 1 amp overcurrent setting. Then I set the baud rate. My particle argon communicates as 150 and 200. And my UART at particle argon is 3.3 volt UART, so I set the expansion port voltage to 3.3. So then my UART will also work at that voltage. Then I do my stuff. So what I do first is I wait for the device, my Argon, to connect to the Wi-Fi network for the first time, and that that means that I will wait for it until it enters the sleep mode, and if it takes more than 40 seconds, then I have a timeout, and this is the initialization phase. Then I start the real test. So I start at 3.9 volt. For each iteration, I drop 300 millivolt. And I will end when I hit 2.7 volt here. So that means that the last recording will be a 3 volt recording. And I look for the message, the sleep mode message. And when I find it, I output the timestamp. I rename the recording to voltage and the voltage that was set. And then I iterate until I'm done. And then I stop the recording. I save this result in a file. and I exit. Okay, so let's see how that works. So now I have the license reserved, so I will just start the code. Voltage sweep. Now it starts measuring, waiting for the first connect. And the benefit of using scripting here together with the UI is, of course, that I can do analysis at the same time as I do an automatic test. So let me hide that window for now. So maybe I'm not interested now at the voltage and current, the power and voltage window. So focusing on the current, I can hide this for now. So now it's doing, after the sleep, it wakes up, doing the connection, and then goes back to sleep. And then it's repeated. So now we are at 3.6 volt, we're going down to 3. So I can then do the analysis at the same time. So here I have an average of 85, 86 milliamp. And the particle argon has a DC-DC converter after the battery connector. So as you see, when I lower the voltage, the current goes up. So looking at the power channel, then I see that the power channel is roughly the same all the time, and that is in line with having a DC-DC converter. I can also see that there is a small change in the power. It's actually lower the lower the voltage is. So perhaps there is the DC converter is more efficient at lower voltages at this current. And it can also be that there is some resistive load in this together with the DC-DC converter as well. So it gives me a lot of information while I do this analysis. Of course, when I have the UI together with scripting, I can get in conflict. If I start turning off power and doing stuff, I can then mess up my measurement. Now you can see that the particle argon didn't like 3 volt. So it's do not connect. So I will hit the timeout here. There. So this is the measurement. It's done. And if I look in the output, I sent out a timestamp each time I found the message. And at 3 volt, I did not find it. So then I stopped the recording and I saved the file and finished. So this was with using the UI. So it's also possible to run without UI, because maybe I have a setup where I don't have any monitor that I connect remote to do the tests. So let's go back to the user manual. In user manual, automation toolbox, there is a command line interface. So what I now need to do is that I need to manually start the OT server. And I can then run it also together with some settings, a config file, if I needed to change the address, for example. And how do I find the server to start? So in here, in the help, there is the find OT server. So now I need to return a license, and I will sign out, because this server, it cannot run together with this, because then it tries to start 2 services. So exit, and I start the server. Move that up to the window here. So as you can see, the server has started, and I can now run the test without having the UI. So now I run a different script. Let me show you what that will do. So the only difference between the voltage sweep and the test server is that I now use auto control. So here I have APIs that enables me to log in and reserve licenses. So I do that here. So after I've done the connection, I log in to my user, and I will look for the first available Pro and Automation Toolbox license here. I can also connect straight to a license with a specific ID. So if I run this as a remote setup, I probably would like to know that there is an available license. So maybe I've tied a license specifically to this remote test. But in this, I will look for the first available license. And I do the same test, and when I'm done, when the test is finished, I return the license and I log out. So a great benefit doing like this is, of course, that I don't risk locking up a license, since the script itself returns the license and logs out. Okay, so let's start our test. So you can see now I'm connected to the server. You can see that the Argon is start flashing and the power is turned on. So now it starts the test. It's waiting for the first connect here, connecting to the Wi-Fi. And now it starts the real test, ramping the voltage. So while we wait for this to finish, feel free to ask a question. I'm happy to answer. I mean, having automated tests like this, it's really beneficial. I mean, for example, if I have several hardwares and I need to look for the variation perhaps in the cutoff voltage where my device stopped working, then I can test several at the same time, lowering the voltage. In this test, I'm taking quite big steps, 300 millivolt step. But maybe if it was a real test, then I would probably have small steps around when I believe that the cutoff will occur. So I get information then from several devices what the cutoff voltage is. I mean, that would take a really long time doing manually. So it's a lot of different things that actually will save a lot of time in your verification and development when you start automating tests. Yeah, so now we're down to 3 volt, and this is also where my particle argon will not find and connect to the Wi-Fi. So if you need help with this tool, if you have questions regarding licenses and purchasing, feel free to contact sales@qoitech.com. And if you on our webpage log in, you will find user management. There is a case system. So if you have technical questions, you can just file a case there, and we are happy to answer. So now the test is done, the license is returned, and I'm logged out. So as you can see here as well, I'm disconnected now from the server. Okay, now the next step to integrate automatic power measurement together with the build server, in this case Jenkins. So my setup for this is remote. So in another room there is a continuous integration setup connected to the build server. So again, there is a particle argon and it's connected through USB to a switchboard here and then continue to the computer. The switchboard here is connected to the expansion port of the ACE, and the main connector is connected to the battery terminal as before. So the reason for doing this is that while I do my power measurement, I cannot have the USB connected to the computer, because then I probably will power up both through the battery connector and the USB cable. So I need to disconnect the USB cable from the computer. And this is what this switchboard does. So if you're interested in knowing more about this switchboard, on our GitHub, there is data about this switchboard with documentation. And also, if you're interested in getting one of this switchboard, feel free to contact us. We have a few of them, so it's possible for us to sell them if you like, as prototypes. Yes, so when a GPO here, the whole switchboard needed power, of course. So one of the pins is a power supply. On ARC it says +5 volt, and on ACE it says 0 to 50 volt. So the switchboard is then powered up through this pin, and then when a GPO is turned high, then it passes through. Then the relays here is switched on, and I get a direct connection from the particle USB connector through the switchboard to the computer. And then I can flash my particle argon. So when the build server has a built firmware, it flashes the device. So you can find this also in the documentation. If I go to the advanced guide again, here's integrating with Jenkins. So here you find a lot of information about this, how you integrate together with Jenkins. And again, here you have roughly the same setup with the switchboard, the ACE, and the argon. In my case, I have USB straight to my device under test. But there's a lot of information here that you might use, but I will also walk you through it here in the Jenkins itself. So here's my Jenkins page. As you can see, we have had some tests being performed, and there has been failures in the test. And the reason for the failure is that this test actually tests if the power consumption goes up, and if it's higher than the previous build. So I mean, this is just an example of how it can be done. So the setup is actually that Jenkins starts a script, a Python script, jenkins.py. So let's walk through that script. So what this script does is that it starts a subprocess that starts the server, and then it starts a unit test where it will run some tests. So looking at the test, it is a lot the same as you have seen before. So there is a connection here to connect to the server to log in. And here, as you can see, there is a specific license that is being used. And when you work with continuous integration, my strong recommendation is to have a dedicated license for this, so you don't risk of stopping this continuous integration because someone else has borrowed the license. Then you connect to the ARC or ACE. And here again, connect to the first one because in this example, there's only one connected. Setting up the ACE, in this case. 4.2 volt, again 3.3 volts for the IO, 115-200. Turns on the power of the pin on the expansion port to power up the switchboard. Then moves over to the flash script, and here in the flash script it's actually doing the connection I talked about. So when the GPO 1 is true, it connects the USB from the computer to the particle argon, and then I can flash my board, and when I'm done flashing I turn off this GPIO. So then the USB is disconnected from the computer and I can start power measurement. And in the test here there's some test performed with main current, reading a GPI as well, and looking at the UART, printing some data about the test, and I also have some limits here when it's a pass or a fail in the test. So we can do this live. So if I start a build, so now I have started a build. Now the switchboard is connecting the USB to the particle argon. So there's LED turn on here when it's passing through. Now it disconnected the USB again. So now powering up through the battery connector here, performing the test. If this software consumes more energy than a previous past build. Let's see when this test is done. In the firmware right now, there is implemented a fault. So the device actually do not go to sleep correctly. And that is also why I have a few failed builds here. So it's finishing up the test. Waiting for the last connection. There. Now the LED of my ACE turned blue, so it's powered off. And the test is done. We can look at the test report. So there are failed tests. Looking at all of the tests. So we have a fail, and the fail was due to that it consumed too much energy. And I can also see here, comparing to an older build. So this is just an example of how this can be implemented. Very simple task here. And as you can see, it's not that complicated to integrate power measurement into your already done function test in your build server. You probably already have continuous integration, and adding power measurement to that is fairly simple. Okay. So that was the end of the Jenkins. So finishing up with the Q&A. So we have had one question in the chat being answered. So while we are in Q&A, feel free to ask questions. I mean, automating gives you a lot of benefits compared to manual testing. You can do long sequences of tests that would require you to sit next to the computer doing your test. But here now instead, you can just start a test and for example, when you leave the office, you can start a long test that will do a lot of tests during the night. And when you come back to work in the morning, you have all the test results you need. There's also big possibilities working with cellular modems, for example. The cellular modems, they have 80 commands implemented. So if you connect to the UART, to the modem, you can control the modem through 80 commands. So you can do an automatic test where you test your cellular modem and trying out different settings with eDirects, for example, trying out that to see how that makes the communication more efficient. Also, on our web page, there is a blog part, so you can read a lot of information there. There is one example together with Thales Gemalto, where we do automatic tests with Python to speed up the testing of cellular modems to set the different settings for the modem with Python scripting. So you will find a lot of interesting articles in the blog. And of course, in the documentation, you will find a lot of information. So thank you very much for attending this webinar. If you have questions later on, feel free to contact us. And also with technical questions, feel free to create cases in our case system. So thank you very much and have a great day.